And according to the video we just watched, it's a mirror image. And normally with a reflection, you reflect across a line. It'll tell you. It'll say reflected across x equals 5, or reflected across the y-axis, or reflected across something. It'll always tell you what they want you to reflect it across. So the line of symmetry is the line that you reflected about. If it says go across the y-axis, the line of symmetry is the y-axis. Also, if you think about just certain figures, let's say I thought about a triangle. And let's say I just wanted to look at this triangle itself. Well, although I'm not going to reflect it, is there a line that if I draw it through it, that it would be the same on both sides, that it would make a reflection? Well, yeah. I could draw it like down the middle right there, and that's called a line of reflection, because if I put that line through the middle, I cut it in half and it's the same on both sides. Some figures have more than one line of reflection. For example, if this was an equilateral triangle, I could draw a line there, and that would also be a line of reflection because both sides would be the same. It would have to be like the same size, the angles and the sides and all that would have to be the same. And if that were true, there would actually be 3 lines of reflection. There could just be one, there could be 2, or there could be more than one. It just depends. Okay? All right. So before we talk about, okay, let's reflect certain things across certain lines, let's remind ourselves what these lines look like. And these lines were, you probably did in Math 1, but for some of you it's been a while, so let's talk about it. When it says y equals 4, what that means is I want to go to the y-axis at 4, and then I want to draw a line through it. Okay? If I go to the y-axis at 4, I have that point right there. Well, if I draw a line through it, is it going to be horizontal or is it going to be vertical? Horizontal, because it's got to go through it, actually. Now, it can go through it vertically, but when that's really going through 0 instead of going through 4. Okay? So that's y equals 4. So y equals -2 means go to the y-axis, go to the -2, put a point, and then draw the line through it. Okay? So y-axis and x-axis are kind of opposite from the way that they describe these lines. Alright, x equals 3. That means go to the x-axis, go to 3, draw a line. So 1, 2, 3, there's 3. So this one's going to be vertical, because I'm going to go through that point, or through that axis. Okay, x equals -1. So I go to -1, draw a line through it. And the reason it's important to know what those are is because some of our problems are going to say reflect it across x equals 2. Reflect it across y equals -1. And if we can't figure out what those lines are, it's going to be harder to figure out how to reflect it. Okay? Alright, y equals x and y equals -x are a little different. Y equals x is one of the diagonal lines. Remember, y equals mx plus b? And b has a 0 right here. So that means it's going to go through 0 because there's not a y-intercept. And the slope is 1 because there's just understood 1 to be in front of that x. So that means we're going up 1 and over 1. Okay? So here's how we're going to draw that line. It starts at 0. You go up 1 and over 1. And so that's the line that's y equals x. It's directly through the middle of those two quadrants. And y equals -x. Basically the same concept, still starts at 0, The slope is negative 1 this time. So instead of going up 1 and over 1, I'm going to go up 1 and backwards 1. So it's just going to change the direction of the line. It's going to be a negative slope, so it's going to be coming down like that. Okay. I think is easiest is to have something in color, which I have some colored pencils back there. I'll get you some in just a second. And like I would highlight it. If you have a highlighter or something colored, I would highlight whatever it says that you're reflecting about. Okay? Okay, so first thing I'm going to do is I'm going to highlight the y-axis. There's the y-axis. So what I'm going to do after I highlight whatever it is I'm going to count, and I'm going to see how far each point is from that line. And then I'm going to draw a point on the other side of the line, the same distance apart. Okay? So this first point here is 1 away from the red. So I'm going to make it 1 away from the red on this side. Okay? So this point over here, beside of it, is 1, 2, 3, 4, 5, 6 away from the red. So I'm going to go 6 away on the other side. 1, 2, 3, 4, 5, 6. I think I did that right. I didn't. There we go. And then the top point there is 3 away. So I'm going to go 3 away up there. Make it at the same place on the other side. And then connect the points. Okay. Any questions there? It doesn't have to be perfect, doesn't have to be perfectly straight, but just enough that we can tell that you counted it and that they're at the correct points. Okay, let's talk about the next one. The next one says that we want to reflect it about the x-axis. So if I want to reflect it on the x-axis, what line am I going to highlight? Is it going to be horizontal or vertical? Horizontal. X-axis. So I'm going to highlight that x-axis right there. Okay, and I want to make sure every point is the same distance away. So am I flipping it over this way, or am I flipping it up and down? Up and down. That's another reason to highlight it, just so that you can see that, okay, I'm going over it, so it's got to go that way. Now, the first point at V, that point stays where it is because it's on the line. So if it's got to be the same distance away, it's still got to be on the line. Make sense? Okay, F. So this time I'm counting how far F is from the yellow. It's 1, 2, 3, 4 away. So I'm going to go 4 below it. 1, 2, 3, 4. How far is Y from the yellow? 2. So I'm going to go 2 below it. And then connect the points. Does it look like it was a mirror image? Yeah. Because it's backwards, and it should be. So number 9 is where it starts getting a little tricky, because it's harder just to sort of look at it. Okay, you do have to count it, but you have to count it from the line that it tells you to reflect it about. Okay, you don't count it from the x and y axis anymore. You don't even use the x and y axis. Okay, so this one says reflected about y equals -1. So first thing we need to do is figure out, well, where is y -1? So I go to -1 on the y-axis, right there, and then I draw a line through it. Okay, so now when you're counting from that line, not the x and y-axis anymore. Okay, so how far is V from that line? 1. So then I'm going to count 1 below it. It's 1 above, so I want to go 1 below. Okay, how far is F from that line? 5, I think. I think you were looking at Y, maybe. Y is 3. But F is 5 away, so 1, 2, 3, 4. We don't have a lot of room, but I'll just put it underneath there because it's one more block. Y is 3 away, so there's a 3, and then we connect it. And it looks very similar to the last problem as far as the shape, but it's at a different location because we reflected it about a different line. Any questions? Okay, let's look at number 10. Number 10 says reflect it about x equals negative 1. Okay, x equals negative 1. So that means that I go to the x-axis, I put a point at negative 1, and then I draw a line. Okay, so this time my figure is coming left to right, so it's going to come over here since that's the line I'm reflecting about. Okay? Alright, so again, we're going to count those points. And just so it's easy for us to talk about them, I'm going to label them so I can talk about them. Okay? So how far is A from the blue line? 2. So I'm going to go 2 on the other side. Maybe. There we go. Okay. How far is B from that line we highlighted? 4. So we go 1, 2, 3, 4. And then how far is C from that line we highlighted? 7. I don't think we're going to have room. 1, 2, 3, 4, 5, 6. So it's like one more block. So just put it out there best you can. And so there's our new picture reflecting across that line. Any questions? It's just tedious, I think. Just tedious. Make sure you're counting it correctly. Make sure you're getting the right line up and down. All right. Y equals x and y equals negative x is a little different. Okay. In the video, they did show you that you could count with y equals x and y equals negative x. But I think it's confusing to do that. Okay, so I'm going to show you a different way. What I think is easiest is to change the points around. I will tell you, if I highlight y equals x, there's y equals x, and I know that this graph is going to flip over it somehow. Okay? And I'm not good in myself at picturing what that's going to look like. Okay? Some of you might see it automatically and know exactly what it's going to look like. But for me, it's a little bit hard to do that. So I'm going to show you a different way. Okay? Here's what we're going to do. We're going to make a chart of the x and y values in the picture they give me. Okay? That seems silly right now, but I'll show you. It makes it really simple to do. So we're going to write down what these coordinates are. Okay? So this coordinate here, we called it A over here. That's 1, negative 2. So I'm going to write 1, negative 2. Okay? B was this point here. So 1, 2, 3, 1. And then C, this point out here, was 6, I think. 1, 2, 3, 4, 5, 6, negative 2. Okay? Are we good so far? Okay, what y equals x does is it flips the points. Okay? So if you make a new chart, you just change it around. So instead of 1, negative 2, it's negative 2, 1. Instead of 3, 1, it's 1, 3. Instead of 6, negative 2, it's negative 2, 6. And those are the 3 points that you draw instead. Okay? So when you switch them, this is the new points that you draw on your picture, and that'll be the answer. Okay? So negative 2, 1, 1, 3, negative 2, 6. So on the next one, we're going to use that same table. We've already written the table once, and it's the same picture. So I'm just going to write that table one more time, just so we have it there. And so what I do with y equals negative x is switch the points just the same way I did in number 11, but then I change all the signs. Okay? So when I switch 1, negative 2, that's negative 2, 1, but then changing the signs becomes 2, 1. Okay? When I switch these, that's 1, 3. They're both positive, so now I've got to make them negative. Wait a minute, you know what? I didn't change that first one to a negative one. That should have been negative, sorry. Okay? Switch these two and change both of the signs. So what would that last point be? 2, negative 6. Okay, let's graph it. 2, negative 1, negative 3, negative 1, 2, negative 6. And I'm going to draw that line y equals negative x just so you can sort of look at it. Because see, to me, that doesn't even look close to being right, does it to you? So as long as I drew it right, I think it's right. But you can sort of tell, like, this part comes over here, so this goes to here, this goes to here, and this part overlapped in between it. Okay?
It's negative 1.
Okay. Yep, there is one point that I messed up on right here. That should have been negative 1, negative 3. See if that makes it look better. A little bit. Okay, so the last thing are some rules about reflections. And it says about the x-axis. Okay? And it says f of xy. Look at the problem that we did up above, that we went over the x-axis. Pick out a point. What happened to the points? What changed? The y value changed when it went over the x-axis. So what that means is it becomes x negative y. The y value changes. Okay? I'll show you some examples of that when we have time, but that's what happens. With the y-axis, if you look at the y-axis and look at those graphs that went over the y-axis, pick a point. What changed? The x value changed. So it became negative x, y. Alright? If it goes across y equals x, we flip the points, right? And so that's yx. It just flips it. Okay, y equals negative x. Flip the points. Change the sign. So it's negative y, negative x.